Okay, we're up and running. Good morning. All right, Hannah Brown, show some leadership. All right, find the particular solution. And you don't have to write this. I'll post it if you want. If you like to write it, it's okay. Find the particular solution to the equation dy dx, the derivative of y with respect to x of e to the x minus 6x squared. Now, then we're going to do an initial condition. That's a mouthful. Initial condition, whose graph passes through the point 1, 0. That's our initial condition. So this will be interesting. A general solution to this would be just the integral of dy dx in general will give us what? The antiderivative of a derivative will give you what? The original function, there you go, equals y, and in this case we'll say plus c. Okay? Sweet! Exactly. And this seems simple and it seems kind of basic, but it's important to remember if you take the derivative of something and then take the antiderivative of that, you get the original function back. It's kind of the basis of why we're here, why we exist. You know, we couldn't breathe, our heart wouldn't beat without this. Right. So let's think about what that means. So that means we're going to take the integral of e to the x minus 6x squared. Ian, you're up to bat. What does that give us? I should say this is the indefinite integral or antiderivative. An integral would have limits of integration here and here. All right, you've had a moment to think about that, to wake up. What a fine Wednesday it is. Rubbing eyes. Lifeline, Jerica. Okay. Be careful. Let's do it in steps. Minus, let's go 6 times. Okay, what power is x going to be 2? 2 plus 1 or 3. And then what coefficient do we put in front of the x? Careful. Okay, JD, remember? Close. You're trying to, don't use this at all. Just ignore this for now. Think only of x squared. 1/3. Excellent, JD. Thank you. Now, Ian, do you see where we got this stuff, sleepy boy? Okay. Everyone looks so asleep. Okay, so we take this, we increment it by 1, we go up by 1, and then we do times the reciprocal of 3. Okay? So Becca, again, head over to the dungeon. It'll be fine. It really will. Well, then ask me. It's okay. It's all good. Because if you have a question, I guarantee you somebody else does. So let's share the love with our cousins. What's up? Oh, man, you two working ahead. Gosh. Okay, so then we have, and we said this would give us our initial equation plus c. So that would be y equals e to the x minus 6 times 1/3, 2x cubed. Okay? Questions so far? Don't forget, remember the video. Plus C. Thank you, Daniel, for that save. Whew. Plus C. I showed you that annoying video, the Bohemian Rhapsody plus C. Okay. Now let's apply the initial condition. Apply the, which was what? Condition. Yeah, passing through 1, 0. I don't know if that's what it looks like. Doesn't matter. Okay, passing through 1, 0. So what's that going to look like? Oh, Jericho. If you're really sharp, you can. But a lot of us are not in the shape yet to say, okay, this is going to be 3, this is going to be 1/3 times 6. If you're really, really sharp, you can do that. But I think at least in the early stages of taking antiderivatives, we should show this step. I mean, somebody like you, sure, if you can see it, go for it. JD? Oh, great question. Great question. Remember way back in the day, e to the x does this. And Euler, who was genius, we're not worthy. Euler, we're not worthy, designed this function so that its derivative would be what? Its derivative would look exactly the same as the function itself, because the dude was a genius. So the derivative with respect to x of e to the x equals e to the x. So the antiderivative of e to the x, wait for it, blow your mind, equals e to the x plus c. Anyway, pretty cool. Tell you what, Euler, we're not worthy. And he was blind for most of it. That's impressive. Woo. I can't answer that question, and probably it's been written about. That's a good question. He had a bunch of assistants that were scribes and described things and helped him with it. Clearly, he couldn't have done it without them, but most of it was just coming from the dude's mind. So smart. And this was before they had Braille, before they had, obviously, technology. I mean, it's really impressive. So, okay. Apply the initial condition. So, JD, did that answer your question? And it was a good question. Okay, so applying the initial condition, who haven't I picked on yet? Anna. It's okay. Let's just look at this. This is just way back when algebra. We have a point here, 1, 0, which we know our graph goes through. And we're not sure what our graph looks like, but it doesn't matter. It might be that, it might be this, but it goes through 1, 0. We know that. Exactly. We can just plug it in. Even if you haven't done it, you can handle that. So what's that going to look like? 0 is y equals e to the first minus, see that, plus c. So this initial condition will tell us exactly the value of c. Okay? You can eliminate c by having limits of integration or by having an initial condition, and that's what we're looking at here. Okay? So let's keep going. Thank you, Anna. Mariah, I haven't picked on you yet. Good morning. All right, talk to me about daughters and lofts and coffee and, yeah. Sure. Mm-hmm. 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 We're on a roll. Okay, minus c. That's cool, minus c. So we get negative, the opposite of c equals e minus 2. And then Divide by -1. Okay, everything. Yeah, they'll probably go 2 minus e is what you'll get. Okay, so then, bring it home, Mariah, you're on a roll. Y equals. Mm-hmm. Mm-hmm. You're my hero, Mariah. Beautiful. So that little single initial condition tells us exactly how high or low this function is. And that is a beautiful thing, ladies and gentlemen. And how far are we into it? Oh, this is a short little video, but 12 minutes. We're good.